Let's look at the ring topology. The ring topology has several hosts, usually drawn in a circle, and they're connected like so, one to the next, to the next, to the next. The key behind a ring topology is that the last one in line connects back to the first one, like this. Now, this has been implemented a couple of different ways. There was token ring, for instance. You've got a sonnet loop. And depending on how you implement this, it can be good or bad. So a token ring is an old networking technology that was used before Ethernet, or perhaps as an alternative to Ethernet. And the way this worked is we generate a token. Think of it like an empty box. And this token travels down the network in one direction, like so. And when the token gets to a host like this, the host says, I'm going to put this information in the token and then send it on its way. And so let's say that it's bound for this guy over here. Well, it has to travel this direction, even though this way is closer because the token only goes around one way. So when the token gets to the next host in line, it says, sorry, I'm full, you can't do anything. So it gets skipped. Goes to the next one. Sorry, I'm full, you also can't do anything. And when it gets to this one right here, it says, hey, this is for you, and it drops off the data. But it doesn't even empty the token yet. Now it just puts a little flag on it, and it says, hey, this has been delivered. And then it comes back to the original host, and that's where it gets unloaded. So the problem here is that at each of these hosts, when the token arrives and it's full, they can't actually transmit anything. Only one device on the network can talk at a time. So token ring is actually pretty awful. Now, we can see other ring networks that are much, much better. So let's take a sonnet loop, for instance. So here's a network over a large distance. So here's my really terrible drawing of Indiana. And up here you have Indianapolis. Down here you have Bloomington. Let's say up here you have Martinsville. And then over here you have Newcastle. So there are 4 cities that we're going to connect via this sonnet loop. So Bloomington is going to connect to Martinsville, which connects to Indianapolis, which connects to Newcastle, which connects back to Bloomington, like so. And you'll see we have that same sort of ring format, one to the next, to the next, to the next, back to the first. Now, in this case, what we have are fiber optic lines that are buried under the roads, or they run up on telephone poles, just depends on sort of what's best for that given area. And this gives us essentially 2 paths to every device on the network. So if we're going from Bloomington to Martinsville, this way, of course, is nice and short. But what happens if you have a backhoe and they're doing some work and they cut this line? Well, now Bloomington and Martinsville have become disconnected, except that the data can now simply travel from Bloomington to Newcastle to Indy to Martinsville. So now there's this separate path, a separate second way to get from point A to point B. And so in this case, the ring topology is very robust. It can withstand multiple failures, perhaps, depending on where they are. And it's also very fast because it's fiber optic cable and the data can travel both directions. So token ring, a bad implementation that we don't use anymore of the ring topology, and a sonnet loop, a very nice one that we do still use.